Hey everybody, my name is Ruben Castro and I'm here with Team Spirits. We have a really exciting yo-yo to show you, so let's just get right into it. This is the basics of what it looks like. We took the butterfly yo-yo design and we wanted to create a yo-yo which looks like a chalice, similar from those of the medieval ages. The top half features hieroglyphs which are embedded onto the piece itself, and the bottom half features 5 injection molded jewels which are press fitted throughout the part. The thermoform discs that you see on the top and on the bottom are just for decoration. And the top one is meant to mimic the way that liquid is kind of wavy when you're swinging it around. And then lastly, there's 2 unique injection molded rings, which are press fit on both sides, which maintain these thermoform discs in place. Up next, Ethan's going to talk about some of our tolerances and some more of the details.
Awesome. So here's just a broad list of our interference fit tolerances. Essentially what's shown here is just only the parts we really care about, which is only the press fits. So our press fits are the chalices and the jewels and the rings. And for the next slide, I can tell you more about how we came up with these numbers. So our goal for the interference fit was 1/100th of an inch. And this was really just determined by literature and reaffirmation from Dan. It's just really what we want to use for polymers for a good fit. Our intuition led us to split the difference by 5/1000ths of an inch for each part, so the male and female parts. We found that the injection molding error range was approximately plus minus 35/1000ths of an inch, and our tolerance was 2/1000ths of an inch, which is significantly less than that. So we have a high error range and a small tolerance. So we assumed we'd make way more parts than we need. Just to start out, we decided to make 20 extra parts of each fit piece. And now for the next slide, Jeremy will give you a rundown of our run chart.
So as you can see here, this is a run chart for our upper yo-yo body, which is the one that has hieroglyphs on it. And as Ethan said, we did about 70 runs of this part because we wanted to have a handful of extras in case some of them did not meet specification. And so as you can see, the standard deviation for this was about 17 thousandths. And even if you exclude the first outlier, it was still 9 thousandths, which is significantly greater than what we'd hoped for. And so up next, Emily will talk a bit about how we handled that.
Yeah, so this slide kind of talks about how we handled our variability. A lot of the injection molded parts we made were smaller than we anticipated. So given that it took us a really long time to mill, especially the small parts like the jewels, we used thermal expansion to our benefit instead of remilling the mold, and put the cooled jewels in the hot bottom of the chalice piece. So that way, like as the chalice shrunk as it cooled, the fit would be better, and also we could squeeze it in while it was still hot. So we performed a drop test on each of these parts to make sure that they held, and I think Shreya is going to talk about what we learned from all this.
We learned a lot of lessons about large-scale manufacturing from this project. Firstly, when there's an issue involving multiple parts, we always fix the simplest mold possible. In addition, early on, we specialized in distributed labor all across the shop. We always had people at the CNCs, the injection molder, and the thermoformer. And this parallelization allowed any mistakes in molds to be found very quickly by individuals with the molding machines. In addition, when we came across an issue between press fits, such as the one Emily talked about, we altered our procedures for assembly before we changed the machinery or the molds. This is because it's easier to change human behavior than metal. For instance, we allowed our press fit rings to stay hot when we assembled if a fit was too tight. And finally, we ensured that quality control was as close to the injection molding machine as possible. This gave us a very quick turnaround when the process went out of control, as we were very quickly able to determine when parts were no longer at the specification. And in the next slide, we'll see a video of our assembly process demonstrating the parallelization I mentioned. So here we're assembling half of our yo-yo body. This is the hieroglyphic side Jeremy talked about. We have an individual on the end drop testing the yo-yos by actually just throwing them on the ground and seeing if the press fit held. We have someone cutting the gates and screws off of the rings and another person press fitting the rings onto the body. And as we'll see, we also have an individual checking all the rings the moment they come out of the injection molding machine to make sure that they're being created correctly. In conclusion, we made 50 yo-yos. They were tested by Dan himself and given a seal of approval. We've greatly enjoyed this class. We've all learned a lot, and thank you very much to everyone for watching our presentation.